Okay, this is the second version of bathymetric boxes. So we're doing now a linear profile graph. So a profile of a feature, a land feature, is like taking a line and drawing a line across that particular region and then just taking the elevation readings across that single line. Here we're doing a profile of a bathymetric box, which is going to be a profile. Each one of these lines will represent a single region of the seafloor, and then we will graph it over here on the graph paper. Now on the graph paper you want to begin with 0 up at sea level. So 0 up at sea level, and then I believe every other one I had the instructions to label in increments of 5, so 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay? All right. And then, so sea level is 0 up here at the top, and we're doing depth readings. We're not going to get down to 50. Let's see, so this is your y-axis, this is your x-axis. Going across is going to be distance from shore, and distance from shore, we started with 0 because that's at shoreline. That's the edge of the box over here that we're not going to measure. And then every third we count in just single increments, so integers, 1, 2, 3. So every third line, 2, 3, and that should give us space to have 10 across the bottom here because we have 10 holes, should have 10 holes. Sometimes if you don't have a full 10 holes, that's okay, but we have space for the 10 distance measurements. So again, depth and your distance from shore. So distance from shore is on our x-axis and depth is on our y-axis. All right, so on bathymetric box. So this time, typically what I do with my my honor students and my oceanography students is I actually have them measure the depth in millimeters and then write that down. But we're going to do this simply, and I think for elementary school students it's much easier if we just use the stick as our measurement and don't have to take those readings and then do a separate graphing of them, because that might get complicated. So you stick the stick in, so you take the center 4 rows of latitude. So each one of these you can think of as a line of latitude, and each of the perpendicular are longitude, but we are going to be getting a profile reading, which is going to be based on depth and how far we are from this shoreline over here. And remember, this is sea level. The paper is sea level. We are working on box C, so we don't know what box C is, but we write box C down to make sure that our teacher can check that correctly. And then we begin our measurements. So to do this, you just stick the dowel into that first row, first row, and then first hole on that first row. Put your fingers at the sea level, pull it up so you know that is your depth reading there. And then we're going to put it on the same row that's labeled 1 down here. And so from the top, we're going to put our fingers at that 0. And so that's how deep the stick was. And we're just going to draw a little dot right there at the bottom of the stick. Okay? So see, that's that. All right. So I'll do that for the others. So as I'm doing that, oops, I will put this a little bit closer to the paper so you can see as I'm graphing that out. All right, So second hole, pull it out, put it right there, and draw my little dot. All right, third hole, pull it out, put it there. So we're keeping about the same at each depth reading. It's not changing too much. It's hard to do this around. That's the fourth, fifth. Still not changing a whole lot. Sixth, sixth, it dropped down a lot right there at number 6. So let's measure that. Ooh. All right. And then number 7. Oh, it's back up a little bit higher again. One, 2, 3, 4, 5, 6, 7, 8. Still up high. 9, still up high. And then 10, our last one, also still up high. So what we have here, based on our first profile, because we will do multiple lines on the same one, you just need to make sure that each of your lines is a different color. So I'm going to make this first one red. I'll color in for red, latitude 1. And then I'm going to connect my dots. So start with 0 and go down. This looks like maybe a continental shelf here, but it dips down really far and then goes back up again. And it's still fairly level. So I would say that looks like a trench as our main feature. Okay, so if we did the other lines of latitude, so if we went down to this one, we could do the exact same thing, continue going across, and I could graph this particular line in blue. Ooh, it goes down deep, back up. Okay, so, so ideally what we would be looking at, so say for instance if I graphed this one in purple, we would look at probably a similar line. There might be some slight variations on this. So you can have several of those lines that are profiling at about the same level. Now that's not necessarily going to be true for every single feature. So if you have something like a seamount, you'll have lines that don't all go in the same direction all the time. So you'll have maybe one that's a flat line and then a couple of them that lift in the middle, and then another one maybe that's more of a flat line. So you say, oh, well, okay, so if you've got flat on either side but a hill in the middle, that might be a seamount. So let's, again, we've made our hypothesis, we've done our data collection, and now we open up our box to check, is our hypothesis correct? And look, that looks like a trench to me. What do you think? That's a pretty cool trench. I like that. All right, so our hypothesis is correct, and we have again gone through the scientific method. We have done research to find out about the different kinds of seafloor before we begin, different features of the seafloor. We need to know that in order to be able to form a hypothesis. And in this case, we did collect one set of data before forming a hypothesis because we didn't have any information to go on. We had no idea what was down there. So we gathered that first piece of information. We said, oh, I think that it's a trench. We continue collecting additional information to confirm our hypothesis. And then, you know, we develop new technology that enables us to actually go down to the seafloor and look